Hello everyone. In this video we're going to be solving a logarithmic equation. Well, it's kind of exponential too. Maybe it's expo logarithmic or logo exponential, whatever you want to call that. Anyways, it's a mixture. So we have x to the power log 25 plus 25 to the power log x equals 10. We're going to be looking for the x values. Here log means base 10 for those folks who think that it is the natural logarithm or the Napier's logarithm. I know some books go by that, but log of x basically means log x with base 10. Okay, all right, great. So I'll be presenting two methods, and let's start with the first one. Okay, some people think that first method is called first method because you use it first. But that's not always true. You could always argue that. Anyways, so I'm going to be using substitution for my first method. Again, one of my favorite methods. I'm going to call log x equal y. Okay, this makes sense because I kind of want to get rid of the log, at least for now. And I want to turn this into an exponential equation if possible, without any logs. I know it's not going to be possible, but it'll be possible partially. So this implies, by using the definition of log, since the base is 10, this means that x equals 10 to the power y. And now I can replace x with that, right? So let's go ahead and do it, and let's see what happens. If I replace x with 10 to the power y, and you know y, plus 25. Now, am I going to be replacing x with 10 to the power y? Well, it is equivalent to replacing log x with y. As long as x is positive, it's in the domain and everything looks good. Because if y is negative, then if x is negative, then we're gonna get into trouble. Obviously a power of 10 cannot be negative, right? That's impossible, at least for real numbers. Anyway, so this is equal to 10, right? And does that mean anything? We have a power of 10, we have a power of 25. Interesting. Let's see. So we're gonna multiply these. Let's go ahead and do that. And then we're going to move this and make it an exponent. Okay. So let's see. So I'm going to use substitution here. So let's write it as 10 to the power log 25 to the power y plus 25 to the power y equals 10. That's kind of interesting because we ended up something like, so at this point, if you want to call 25 to the power y something like, let's say, okay, 25 to the power y is equal to z, you're going to get something like 10 to the power log z plus z equals 10. Isn't that interesting? Okay, you could probably proceed this way. Well, I wasn't planning to do it this way, but that's okay. We could also do it differently, a little differently, like, we could call this log 25 to the power y something, and then go from there. But anyways, we could just proceed with this one. So now I have 10 to the power log z plus z equals 10. So that's kind of nice because I have a single expression. I still have a log, but it's not as bad. At least I don't have two logs. To solve this, what can I do? Well, maybe we can try to simplify this expression right here. What is 10 to the power log z, right? So I don't know what it is. So let's call that t. I don't know. You can use any variable besides x and y, I guess. So how am I going to find out what this is? Can I turn it into something in terms of z? And to understand, the best way to do it is by logging both sides. So let's go ahead and log both sides. Since if I don't know anything about logs, at least we can log both sides, right? And now I know this property. You can move it to the front. That just becomes log z times log 10 equals log t. Awesome. And log 10 is base 10, so it's just going to be 1 by definition. And I end up with log z equals log t, meaning that z is the same as t, or t is the same as z. Okay, but I call this t, so it is z. In other words, I get the following equation from here. Z plus z equals 10, so z equals 5, because 2z or not 2z, yay. Okay, z equals 5, but what is z? It is 10 to the power, oopsies, that's not the case. Z is something else. Okay, z is 25 to the, oopsies. Z is 25 to the power y, too many oopsies. So I can write it as 25 to the power y is equal to z, which is 5. And now 25 is 5 to the second power, so this becomes 5 to the power 2y equals 5. I hope you don't mind me skipping that single step, which is 5 to the second to the y. And now here 2y is equal to 1 and y is equal to 1/2. Again, we're not done yet because we're going through so many loops. I know that. And we're just gonna back substitute. Okay, y is equal to 1/2, but what is y? And why did we call that y? Okay, great. So y is equal to log x. Awesome. Let's go back here. So y is equal to log x. This means log x is equal to 1/2. Yay, finally. From here, since the base is 10, that means x is equal to 10 to the power 1/2, which means x is equal to square root of 10. And yay, it's in the domain because square root of 10 is greater than 0. Remember, we have to check the domain. Log x is only defined when x is positive. Awesome. Was this the first method? No, it was the second method, right? Okay, this was the first method. Let's go ahead and talk about the second method. Okay, great. I thought this was the second for some reason. I don't know why. Anyways, maybe the video was too long so far. Okay, so second method is obviously simpler. And remember, our equation was x to the power log 25 plus 25 to the power log x equals 10. By the way, this is a homemade problem. It's easy to make. These problems are very easy to make, and you can also make one of these. Okay, great. At some point, I can kind of talk about how I made up some of these problems, especially with functional equations. I want to talk about it. Anyways. That's a side issue. So I'm going to call this x to the power. I'm going to call this y. Again, I'm using my favorite method. And I'm going to call this z. Okay. Apart from the first method, forget about those y's and z's. So now, since I made this assumption that x to the power log 25 is equal to y, let's go ahead and log both sides again. And that's going to give us log x to the power log 25 is equal to log y. And if you move this to the front, you're going to get log 25 times log x is equal to log y. Here, nothing cancels out because we don't have 10 or power of 10, but that's okay. Let's do the same thing for z. Now I have 25 to the power log x is equal to z. And again, logging both sides is a wonderful strategy for equations like this, for exponential and logarithmic. Similarly, and if you move the log x, that becomes a coefficient or a multiplier or a factor, whatever you call that. Anyways, what do you notice, right? Something interesting you should notice here. Well, the left-hand sides are the same. Log 25 times log x is the same as log x times log 25. So these two quantities are equal. What is that supposed to mean? It means that log y is equal to log z, which means y is equal to z. But what is y and what is z, right? This is y, that's z. So they're equal. Well, they're going to share the 10 equally then. So you can write this as y plus y is equal to 10 and y is equal to 5 because 2y is equal to 10. But what is y? Y is equal to this one. So let's go ahead and go with that one. You could also go with z, which is probably a little easier to solve. But anyways, let's just solve this equation. How do you solve it? Again, you can log both sides. And you can say, hey, log 25 times log x is equal to log 5, a lot of logging. But log 25 is log 5 squared. And, it's just going to be written as 2 times log 5 by using the properties of logs. And log 5 is not 0. It's not 0, so we can go ahead and cancel that out. And that gives us not 0, 1, 2 log x equals 1. And log x equals 1/2. Again, it's going to be x to the power x equals 10 to the power 1/2, and that's going to give us square root of 10 as normal, right? That's the first method, what that gave us, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. Especially if you have a third method, please let me know. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.